Hi, everyone, and thank you for joining today's webinar. In this session, we'll talk about how customers can accelerate an organization-wide modernization strategy by enabling Cloud Center of Excellence, CCOE. My name is Svetlana Kolomyskaya. I'm a go-to-market specialist lead for Serverless, and I've been with AWS for over 3 years, and I've been helping customers develop and roll out an enterprise-wide strategy for cloud-native modern applications. And I'm presenting today with Bhavna Sarathi. Bhavna, would you like to introduce yourself?
Thanks, Svetlana. Hi, everyone. I'm Bhavna Sarathi, Senior Container Services Go-to-Market Specialist at AWS. I work with customers on their AWS Container Services adoption and also provide guidance on their enterprise-wide application modernization strategies. I have been with AWS in the Container Specialist role for about a year, prior to which I've spent 10 years in product management, bringing new products to market. And I started my career in engineering. I'm really looking forward to speaking to all of you. Svetlana, back to you.
Thank you, Bhavna. During today's session, we will talk about the evolution of modernization strategy. Then we'll talk about the role of the Cloud Center of Excellence, CCOE, in the organization-wide adoption. And then we'll cover key operating principles and guardrails that we see customers consider when establishing an organization-wide strategy. So based on a study from Deloitte, CIOs tell us that most IT organizations are still dedicating majority of their resources in keeping the lights on. So 80% of developers' time is still spent on operations and maintenance of applications, and only 20% is spent on innovation. And CIOs would like to reverse that ratio, and they want development teams to build modern applications. They want to offer new customer experiences and create innovative ways to help their customers. And part of the reason this level of change is now possible is due to the evolution of compute technologies. In recent years, we've seen a paradigm shift to containers, to serverless, as companies are looking for deeper agility and efficiency to their operations. We all began with physical machines, where our ability to scale and change and innovate was very limited. I started out my career as a developer, and I remember sometimes it took 2-3 months to get a new environment provisioned for me. And then gradually, we moved to virtual machines, virtualization, where we started to experience faster speed and agility. And then the third wave is containers. Containers provide benefits such as platform independence and fast deploys. Let's say you're running something on-prem and you want to keep those investments, yet be able to run that in production in the cloud. And containers, they allow you to package your applications and move them between different computing environments. And then there's serverless. With serverless, you don't have to worry about any of that. So now with serverless, customers can focus on what matters the most to them, their secret sauce, their business application logic. And then AWS takes care of things like server management, maintenance, scalability, and high availability is built in, and there are cost benefits as well due to pay-for-value cost model. We have 2 key compute services at AWS. AWS Fargate, which is a serverless container solution. Customers do not have to worry about any container post-instance management, and they love that there's low operational overhead. And then with AWS Lambda, which is an event-driven service, developers write their code and then simply upload their code, and Lambda takes care of everything required to run and scale the execution to meet an application load and high availability. And then Lambda supports multiple programming languages, such as Java, Node.js, Python, and most developers are already familiar with those languages, so it's really easy to get started. And similar to Fargate, server management, security, scaling are all managed by AWS. So in the past, we saw that customers would go through a lift and shift process first, and then start looking at modernization initiatives. Now we see more and more customers starting their modernization journey much early in the cycle, and often in parallel with moving applications to AWS. And as part of that, many of our customers started defining what we call an organizational-wide modernization application strategy, and which is a decision to select cloud-native technologies, serverless and container services in your application as the first choice. And this is for both net new applications, but also refactoring existing applications. With lift and shift or migrating applications to the cloud, customers get tremendous benefits. And the modernization application strategy allows customers to get to that next level, right, to the next step, to get the maximum value of the cloud. And then customers can focus on building highly scalable, secure cloud-native applications and deliver to your customers quickly. We see many paths towards that type of organization-wide modernization adoption, but we've seen one pattern emerge most commonly, and we refer to it as the organic adoption pattern. And it starts with developers. And developers get really excited about new services and new way of building applications. So they start to experiment. They start to develop proof of concepts, develop simple apps. And then based on that success, we see that perhaps one or two business units start launching maybe a business application with serverless and containers. And it could be a net new application, but also could be refactoring of an existing application that might have been not performing well or maybe too costly. And then we see a tipping point. That's where we see somebody from the leadership side, they notice the benefits from this business application. That could be low cost or fast time to market. And that's where we start having a more strategic conversation with that executive, with that leadership team on defining the next generation modernization strategy, leveraging serverless and containers. And this type of organizational change cannot happen without the right level of support for executive sponsorship. We see that customers who are most successful, they set organization-wide direction at the executive level. And that could be C-suite, head of cloud, head of CCOE, head of architecture with the technical decision makers. And then this decision is communicated across all the development teams. And it really talks about that this approach enables customers to achieve the maximum value of the cloud so that developers can focus on building products that drive their business. And then executive sponsors, they also help with vision setting, right? They focus on questions such as whether you want your business to be in 3 to 5 years, how can you keep up with the pace of innovation that's demanded by your customers, but also stay competitive? Also, how can you keep your development teams focused on building applications and not managing the underlying infrastructure? Also, executive sponsors, they can also help with organizational changes, right, if needed, to promote this type of transformation. We have many customers who build modern applications, and here are some of the great success stories that we see. For example, we have Comcast, who built an integrated experience with Netflix in just 4 months, and that enables their team also to move faster. And also they're excited to attract the best talent, also cutting costs as well. We have customers like Capital One, who now started launching new features in weeks versus months or years. We have customers like McDonald's, who built and launched a home delivery system in less than 4 months, and that's in response to COVID. And that system now scales to 20,000 orders per second with less than 100 millisecond latency. And then we have many other customers like Coca-Cola, like Amenity, that deliver innovative solutions to their customers, leveraging serverless and container services. Now, another example I want to talk about is Liberty Mutual. Liberty Mutual is one of the customers who defined a organizational-wide serverless serverless-first strategy for the organization. And Liberty Mutual is an over 100-year-old global insurance company, and they started their cloud journey about 10 years ago, and then they defined a serverless-first strategy with Lambda, with Fargate, somewhere middle of 2019. And that decision was driven by their executive CIO office. And then Liberty Mutual communicated that type of a strategy to all of their developers, and they leveraged a document they're calling Technology Manifesto. And in that document, they noted down their overall strategy, right? That the goal is to keep the pace of innovation and focus on their customers. And then also they talked about focusing on building applications and not managing the underlying infrastructure. And then the adoption of that strategy has been driven by their central architecture team, the CCOE team. And that team defined a set of guardrails. They also defined reusable templates, CDK patterns, best practices overall. And they developed 3,500 serverless patterns in 1 year, leveraging AWS CDK across various applications. And then Liberty Mutual started launching pilot projects and got their teams really, really excited. And they started sharing their success stories, started sharing their metrics. As an example, they launched a virtual assistant. Virtual assistant is a truly serverless natural language processing system that resolves many queries. And today it handles 200,000 calls per month at 4 cents a call. Or they launched a financial center service, FCS application, that today processes 100 million significant financial transactions per month. As part of the architecture, they leverage step functions, express workflows. And then that specific component costs them $60 per 1 million transactions, right? And there are many more examples like that, and I just named a couple, but they have more stories to share, and they're launching those projects as a result of defining a serverless-first strategy. So, as with Liberty Mutual example, to enable scale for customers who are looking to roll out an organizational-wide modernization strategy, we typically engage with customers' Cloud Center of Excellence teams. It's called Cloud Center of Excellence CCOE team in some organizations, but not for all organizations. Sometimes it's called by other names. It could be Architecture Guild. It could be Central Architecture Team. But that's really the function, right? That those teams are typically responsible for defining a consistent way to apply organization-wide guardrails, best practices, governance, architecture guidelines, guidance, and also they enable their development teams to get started by leveraging reusable patterns and templates. Now, when teams typically start developing applications, whether it's serverless or containers, lots of questions are coming in from these various development teams. And questions often they differ based on the team or based on the persona. And the role of the CCOE is to work with all these teams and establish best practices, provide guidance for these questions. And then CCOE helps scale these areas so these teams don't have to reinvent the wheel and keep addressing the same questions over and over again. So what makes up the CCOE? Many companies already have an established CCOE. But typically, these teams are responsible for things like account creation or IAM policies. So in that case, we typically see that the role of that team will expand in scope to include cloud-native workloads, serverless and container services. And then if there isn't one today, then customers establish a new team by recruiting influential members or experts from cross-functional teams. So it could be from security team or DevOps, architecture, infrastructure, or the database team. And then in most cases, it's a dedicated team, but we've also seen successes with customers with virtual teams as well. There are three key areas where CCOE team can help define and scale best practices, and that's around people, technology, and process. And the CCOE team serves more of a governing authority to establish and promote these best practices. So let's look at some examples. From a people perspective, CCOE teams, they act more of a set of ambassadors for other teams. And that's why also it's important to have different people represented across different groups as part of the CCOE. They're also influencers, and they promote things like education. Education not only around cloud computing, but also AWS services, serverless, and containers, but also companies' best practices with these technologies. Also tooling selection for areas such as observability, monitoring, and logging. And there are different techniques to education. So it could be things like self-paced training, immersion days. So immersion days can be done with the help of AWS, or we've seen also train the trainer sessions that were very successful as well. We've also seen customer CCOE members embed themselves with development teams who are new to cloud native development, perhaps just for a couple of sprints and just to help them get started. Also, these teams promote AWS certification uptake. So even have some fun competition between teams to see which team has the most certification and have some prizes as part of that. We've also seen organizations run hackathons as well. So hackathons are always fun, team building activities, but they also reinforce the knowledge and also allow developers to come up with innovative ideas. CCOE teams also offer ongoing communication with teams, whether it's a new pattern that's been launched or best practices were introduced for a specific area. And then as organizations become more mature, they also promote community building and share successes, or perhaps there's a team that created a new architecture pattern that can be shared with other development teams as well. Now, on the technology side, CCOE evaluates and recommends tooling to be used, for example, for observability or for logging. So this way, there's consistency between teams and less of a learning curve for developers. And then they also define a set of guardrails and best practices around areas that include security compliance, DevOps, CI/CD, observability, monitoring, maybe cost management to set the structure up front so it's not an afterthought. Also API management and testing strategy. So the guardrails and best practices, they are there to accelerate initiatives, to act more as an enabler, right? So teams, the development teams still have some freedom to innovate, try new architectures, and also experiment. So now the combination of these guardrails or best practices and reusable patterns, so together they adapt to a paced path, which is what CCOEs are aiming for. And then Bob now will give some very specific example of guardrails and best practices later in the section. And also with actual reference implementation, and that's shared services architecture, that's where CCOE are focusing on as well. And then in terms of process, CCOEs, they help teams on improvements to processes as a result of leveraging cloud-native workloads. For example, DevOps and CI/CD full automation for all the microservices within a specific application, or perhaps improvements to testing automation processes for things like unit testing or integration testing. And then CCOE teams also often conduct architecture and well-architected reviews for key applications, and that's really there to ensure that the best practices are followed. So it's not a mandatory step, but it's highly recommended. And then CCOEs, they help with defining onboarding curriculum and learning paths for developers, it could be architects and all other teams within the organization. And they also help define account strategy and team structure as needed. And then, of course, we from AWS, we partner with those teams, with the CCOE Central Architecture team, and we help define these best practices based on the learnings from working with other customers. And now I'll pass it to Bhavna Sarathi, and she'll talk about some specific example of operating principles and guardrails that CCOEs might be focusing on.
Thanks, Svetlana. In this section, you will learn about the importance of establishing operational guardrails and best practices for 6 key app modernization areas: security and compliance, DevOps and CI/CD framework, observability, monitoring, and logging, iterative application modernization, architecture patterns, and lastly, cost management. The first app modernization area we will look into is security and compliance. Security and compliance is an important area in planning out app modernization projects, where the central architecture team provides the operational guardrails to the development teams. For this reason, some CCOE teams either have security experts within their team, or the CCOE works very closely with the security teams in their organization. While providing the best practices and guardrails, it is important for the central architecture team to not be gatekeepers and create a bottleneck. You want to provide development teams with the freedom to innovate and develop within the security and compliance guardrails you have laid out. Security and compliance is a shared responsibility between AWS and the customer, which is defined in the AWS shared security model. Let's take a closer look. AWS is responsible for security of the cloud, for protecting the infrastructure that runs all of the services offered in the AWS cloud, relieving the customer from the operational burden of managing the infrastructure. The customer is responsible for security in the cloud, which includes configuring the IT environments in a secure and controlled manner. You will have to understand how this applies to serverless and containerized environments such as Lambda, Fargate, ECS, and EKS. As the central architecture team, it is your responsibility to set guidelines for your development teams. One of the primary benefits of serverless is that AWS takes on a greater share of responsibility for security operations. This does not mean that security is free. As shown, customers are still responsible for application layer security, authentication and authorization, data encryption and integrity, monitoring, and logging. Here are some security and compliance considerations. You should clearly define access requirements for automated or programmatic access to reduce the risks from unnecessary privileges. Follow the principle of least privileges when granting a human or an application access to AWS resources. You should provide guidelines on the tools used to detect and investigate security events. This provides a uniform way for teams to capture and analyze events from logs and metrics to gain visibility. Key indicators should trigger automated alerts when they breach the thresholds you have set. You should define protection controls for compute resources such as EC2 instances, containers, AWS Lambda functions, database services, and more. You could also identify different types of data consumed and produced by your workload. This will help you determine appropriate data protection and retention controls. The second app modernization area we will look into is DevOps and CI/CD. Development teams are increasingly adopting DevOps practices to improve the speed and quality of applications built, tested, and delivered. Customers adopt containers and serverless technologies on AWS to rapidly deliver applications and easily scale with customer demand. Clearly, app modernization with containers and serverless dovetails into the DevOps practice. As leaders in your organization, many of these benefits, like improved collaboration, reliability, security, rapid software delivery, scaling your application, are all things you care about as well. Success with DevOps automation requires adopting the right tooling across the entire development cycle. Let's now bring our attention to CI/CD. Continuous integration is an automation process for developers. CI is where new code is regularly built, tested, and merged to a shared repository. Continuous delivery usually means developer changes to an application are automatically tested and uploaded to a repository like GitHub, container registry like ECR, etc. The code can then be deployed to a live production environment. Continuous deployment refers to automatically releasing a developer changes from the repository to production. CD is an excellent way to accelerate the feedback loop with your customers. Based on the State of DevOps report, businesses that adopt CI/CD best practices note that the deployment frequency increases daily or even several times a day, from weekly and monthly releases. Lead time for changes refers to how long it takes to go from code commit to code successfully running in production. Embracing DevOps and CI/CD results in reducing that time frame from 1 to 6 months to 1 to 7 days. Change failure rate. This refers to what percentage of changes committed results in degraded service, requiring remediation such as service impairment, outages, rollbacks, need for hot fixes, and so on. We've all seen this before. The change failure rate reduces from a high number of 46 to 60% to just 0 to 15%. We hear from some of our customers that a central architecture team provides guidance to the development teams on the appropriate CI and CD tool choices. They also provide guidance on the process changes and ensure teams receive adequate training on the chosen CI/CD tools. Some of the DevOps and CI/CD considerations includes evaluating tooling across the entire development lifecycle, choosing the right framework for the business need, and increasing integration testing. Some other key strategies include canary and blue-green deployment, automated Lambda power tuning in the pipeline, automated testing, and validation of security controls in pipelines. The ultimate goal of adopting DevOps and CI/CD automation is to improve the speed and quality of how applications are built, tested, and delivered, thereby meeting the business objective of supporting customers efficiently and increasing revenue. The third app modernization area we will look into is observability monitoring and logging. The best way to ensure you're making the right decisions for a running application is through the knowledge cycle. You need to make informed decisions on what you will monitor, which provides you with the right insights to take action when something is not working properly. The best way to capture that is through a monitoring plan, which consists of the people, the decision makers and the developers, context through system knowledge, telemetry data, and insights from monitoring tools, which finally leads to the action that you will take. Observability and monitoring gives you visibility into how your application and resources are doing. When you deploy code changes or make infrastructure changes, having good observability allows you to troubleshoot issues in real time. All of this enables you to provide your customers with a great experience on your website and services. Lastly, application and performance and uptime has a direct correlation with your revenue. Observability in the cloud means we need to collect three things: metrics, logs, and traces. Metrics is useful for identifying trends. Traces provide visibility into the path traversed by the request in a distributed system. And logs are useful for uncovering emergent and unpredictable behavior. We are building our observability tools on a strong building blocks that we already have in terms of logs, metrics, and traces on Amazon CloudWatch and AWS X-Ray. The AWS Observability Tools are not only feature-rich, but also extremely easy to set up and maintain. For users that want to adopt open source tools for their observability needs, we have AWS Distro for Open Telemetry, which is a secure, production-ready, AWS-supported distribution of the Open Telemetry project. Using ADOT, customers have the ability to use open source observability solutions like Prometheus for metrics collection, Jaeger for tracing, and many other monitoring tools from vendors like Datadog, New Relic, etc. Here are some observability and monitoring considerations that the CCOE team can influence. In response to an event or incident, use monitoring dashboards or reports to understand and diagnose the impact. The dashboard views provide insight into which portions of the workload are not performing at expected levels. Identify the KPIs that indicate whether the system is performing as intended. For example, an API-based workload may use overall response latency as an indication of overall performance, and an e-commerce site may choose to use the number of completed purchases being made as its KPI. Your application code will have to be instrumented with appropriate libraries to capture such data. As routine maintenance or in response to events or incidents, review which metrics are collected. Use these reviews to identify which metrics were key in addressing issues and which additional metrics, if they were being tracked, would help to identify, address, or even prevent issues. The fourth app modernization area we will look into is iterative application modernization. Say you have a monolith application that provides business value to your customers, and it is a very important revenue generator for your company. I'm sure you've heard statements like, let's move to a microservices-based architecture. Let's convert our monolith to microservices, but we need to handle the customer data carefully. You are heavily dependent on the application. So how do you do this safely? A popular pattern that we have seen our customers use is the Martin Fowler's Strangler pattern. Gradually create a new system around the edges. Over time, the old system is strangled. I have seen this methodology used to move specific data sets from a giant monolithic database to a purpose-built AWS database like DynamoDB, and using an AWS data lake to significantly improve data access and performance. This retail example showcases the Strangler pattern applied to an application architecture. The shipping service data tier is separated into a purpose-built database and a microservice created to handle the shipping needs. The newly developed service will present you with an opportunity to architect the microservices in a way that best suit the needs of its job. Its intention is to do one job and do it extremely well. Next, the inventory capability gets its own microservice, followed by the order service. The shopping cart, which is very visible to the customer, remains in the monolith to ensure that there is no disruption of customer service while the application is re-architected. You'll continue stripping out capabilities from the monolith until it is replaced by microservices, at which point you can now eliminate the monolith application. The key thing to note, though, is both the monolith and the microservices will live together for a period of time. There are other patterns, such as the facade pattern and adapter pattern that you can adopt as well. When speaking to our customers who have moved to the microservices architecture, we have learned that the architecture team plays an important role in deciding the pattern or combination of patterns to follow that is best suited for their organization. It takes careful consideration along with application architects to select the functionality to convert to a microservice that will provide the most benefit to the customers and the internal teams. At times, it might be too risky to the business for a critical application functionality to be transformed, and the decision to maintain it has to be made. Also note that the purpose-built database selection is a key decision that involves data protection in transit and rest, user access management, performance at scale for large data sets and transaction volumes, auditability of database activities, and database replication. Lastly, the teams working on the app modernization projects will need hands-on training to come up to speed on containers and serverless technologies, and also iterative app modernization concepts. The fifth app modernization area we will look into is architecture patterns. Here is a REST API implementation using Amazon EKS for container orchestration. We use AWS API Gateway endpoints secured by AWS Certificate Manager. The gateway handles the incoming call, which are authorized using custom authorizers built using AWS Lambda. Then, through the use of the API Gateway private integrations, we can route the calls to services that are running in a EKS or even ECS cluster, which handle all of the processing. The workloads in the cluster could be talking to the backend database running under our Amazon RDS. And we can use AWS X-Ray and Amazon CloudWatch across the stack for capturing traces, metrics, and logs. Single-page web applications are very popular and a great fit for serverless. In this example, AWS Amplify is used for the static web hosting, and the Amplify library is used to integrate with Amazon Cognito for authentication. The backend is fully serverless. With the API layer in API Gateway, the business logic in Lambda, and state being stored in DynamoDB. This pattern is very popular because the static costs are very low and the whole stack is serverless, scaling up and down seamlessly. Let's look at a practical example from the airline industry. This last example is an application that consists of a number of different serverless microservices. There's a serverless web app, backend REST APIs, as well as GraphQL APIs. There's also serverless orchestration with step functions and many others. In addition to the infrastructure as code templates from these components, the project also contains the sample application code. This project is out on GitHub, so I encourage you to take a look. The central architecture team often builds out example patterns that is most applicable to your business, which could be web apps or mobile apps in any industry. These patterns are built as infrastructure as code templates using platforms such as CloudFormation, CDK, or Terraform. But patterns are only the beginning. We see customers build an internal community to improve the patterns and create new ones. Development teams don't have to think as much on the underlying infrastructure and can focus on solving the business problem. A development team will pull a pattern into their repository and then they own it. It is useful to create mechanisms for teams to share feedback about the patterns. As you develop these patterns, you want to create a well-architected review team and run the patterns through a well-architected framework, which consists of operations, reliability, security, performance, and cost. AWS can assist with running a well-architected review. The last app modernization area we will look into today is cost management. Cost management is a set of activities that enable organizations to measure, optimize, and plan costs as you grow your usage of AWS. These activities span 4 distinct areas, including measurement and accountability, activities that establish cost and visibility to ensure transparency and accountability for spend. Cost optimization, activities that ensure your organization pays only for the resources it needs. Planning and forecasting, activities that allow your organization to better understand costs associated with future cloud workloads. And lastly, cloud financial operations, activities that enable your organization to scale cloud financial management. We start with measurement and accountability, an area of the framework that focuses on capabilities that enable organizations to establish cost visibility and accountability for spend. So these include things like leveraging accounts and tags to create a representation of how workloads and organizations are mapped to their AWS consumption, building the right level of granularity for cost reporting, and monitoring for stakeholders to enable real-time decision and avoid cloud budget overruns. Allocating cloud costs by implementing chargeback for cloud spend and including spend on commitment-based purchase plans, shared services, and marketplace purchases to drive a really cost-aware cloud consumption. And finally, measuring and reporting cloud efficiency and value KPIs, enabling organizations to measure the impact of cost optimizations and validate expected versus actual value creation. Cost optimization is the second area of the framework, and it focuses on capabilities that enable organizations to pay only for the resources they need. These include ensuring architectures, solutions, products, and deployments are designed and operated in the most cost-effective manner from the get-go to avoid incurring technical debt. Identifying and recouping spend associated with cloud waste for cloud resources that are already deployed. This happens when we incorrectly size resources or observe usage patterns different than what we expected them to be. We can take those savings and do something more productive with them. Using the best purchase option to drive down unit costs for your workloads, and I'll come back to this point in the next few slides. And finally, reducing TCO of cloud whenever AWS innovates on your behalf by adopting new services, regions, features, solutions, or price reductions. Savings Plan is a pricing model that offers significant savings on Amazon EC2, AWS Fargate, and AWS Lambda usage. Savings Plan requires customers to commit to a consistent amount of usage, say $10 an hour as an example, over 1 or 3 years, and in exchange, customers will receive a lower price for that usage. Savings Plan offers significant savings, just like reserved instances, but with greater flexibility. Amazon EC2 Spot instances will let you take advantage of unused EC2 capacity in the AWS cloud. Spot instances are available at up to 90% discount compared to on-demand prices. You can use Spot instances for various stateless, fault-tolerant, or flexible applications such as big data, containerized workloads, CI/CD, web servers, high-performance computing, and test and development workloads. AWS Graviton2 powered instances have the highest performance within their instance families, along with 20% lower cost when compared to other instances with the same vCPU and memory configuration, which leads to up to 40% better price performance versus comparable x86-based instances. This is the best price performance within their instance families and leads to real savings for our customers. AWS Graviton is available on EC2, ECS, EKS, Fargate, and also Lambda. Planning and forecasting is the third area of the framework focused on capabilities that enable customers to improve business predictability for current and new cloud workloads. Evolving your current budgeting and forecasting processes to become more agile and dynamic to accommodate more variable nature of cloud consumption. Leveraging new methodologies to estimate the cost of workloads using AWS tools like Migration Evaluator, AWS Pricing Calculator, or how about just doing a plain old POC that is deployed to a test account, tagged, applied a load against, and measured. A large part of the value customers realize when using cloud goes above and beyond just cost savings. As such, it's important to quantify expected value creation across staff productivity, operational resilience, business agility, to build a data-driven process when considering future workload migrations or even benchmarking value creation for existing cloud workloads. And finally, many customers live in a hybrid world because they are in the middle of a digital transformation accelerated by cloud. To enable a holistic end-to-end view of the entire IT estate, it's important to integrate your cloud planning processes with those that you currently use for your on-premise IT. Cloud financial operations, our fourth and final area of the framework, focuses on capabilities that enable customers to evolve organizations, processes, automation, and tools and establish a self-sustaining, cost-aware culture of innovation. Secure executive sponsorship to establish a cloud financial management owner or team that will establish a standardized programmatic approach to cost management, which can drive real results and quantify cost and value outcomes compared to isolated and ad hoc efforts. Ensure stakeholders across the organizations have common understanding of cloud costs. This can be done through reporting, education, gamification, celebrating efficiency wins, and establishing new working partnerships between finance and technology teams to enable more accurate budgeting and cloud spend monitoring. Building guardrails that help maintain or increase the agility provided by cloud without having to worry about costly cloud mistakes like unintentionally provisioning the beefiest resources types or accidentally leaving resources running over the holidays. And finally, evolve existing mechanisms to help proliferate cost efficiency in a continuous manner across your cloud journey. Whether you're early in your app modernization journey or you have already started using containers and serverless technologies, here are some actions we recommend. Set up an EBC to speak to AWS executives about the benefits of application modernization and moving to cloud-native tools provided by AWS. Establish a CCOE team for cloud-native workloads to provide guardrails and best practices, or augment an existing CCOE to include cloud-native technologies. Launch pilot projects in parallel to CCOE enablement. Best way to move forward is by doing. Lastly, engage your AWS account teams, compute specialist teams, and partners as you progress on your app modernization journey. Thank you so much for your time, and please reach out if you have any questions.